All right, welcome to The Explainer. Today, we're going to tackle a huge topic, artificial intelligence. What is it really? We're going to peel back all the layers of science fiction and get right down to the simple, powerful logic that actually makes the whole thing tick. So let's just dive right in. What is AI? If you ask 10 different people, you'll probably get 10 different answers. But inside the actual field of AI, things are, well, they're a lot clearer and more structured than you might think. And it turns out there are really four main ways to think about it, all based on the answers to two simple questions. First, are we trying to make something that acts human or something that acts perfectly rational? And second, are we judging it based on its internal thought process or just its outward actions? This simple grid gives us four totally different goals for what we're trying to build. Okay, so let's start with that first box, acting humanly. This is where you find the famous Turing test. The whole point here isn't to figure out if a machine is actually thinking like us. Nope. The question is much simpler. Can it act so human in a conversation that we literally can't tell it's a machine? To pull that off, an AI would need to be a master of language, it'd need to understand the world, and it'd have to learn as it goes. Now, let's jump over to another corner of our grid, thinking rationally. And this idea, it's old. We're talking Aristotle old. The whole idea here is that intelligence is just pure, cold, hard logic. It's about building a system that follows these perfect laws of thought to come to flawless conclusions, just like the classic example you see right here. Now look, all four of these are totally valid ways to think about AI. But the one that's been the real game changer, the one that actually helps us build the stuff we use today, is acting rationally. This isn't about perfectly mimicking how humans think, because that's messy. And it's not about pure logic floating in space. It's just about one thing: creating a system that does the right thing to achieve its goals. And this idea, this focus on doing the right thing, well, that leads us straight to the absolute core concept in all of modern AI, something called the rational agent. So what on earth is a rational agent? It sounds complicated, but I promise it's not. It's just a fancy term for anything that can look at its surroundings, using sensors, and then do something, using actuators, all to get the best possible result. Basically, it sees, it does, and it tries to win. Simple as that. So, how do you actually design one of these things? Well, engineers use this super handy framework called PEAS. P-E-A-S. It's an acronym that forces you to nail down the specifics by asking four key questions. P for performance. What does a win even look like? E for environment. Where is this thing operating? A for actuators. What can it actually do? And S for sensors. What can it see or perceive? All right, let's make this real. Think about a self-driving taxi. For P, performance. What's a win? A safe, fast, legal trip. For E, environment, well, it's the total chaos of city streets, right? Traffic, pedestrians, everything. A, actuators. That's how it acts. The steering wheel, the brakes, the accelerator. And S, sensors. That's its eyes and ears. Cameras, GPS, all that tech. Defining the problem this clearly is what makes it possible to solve in the first place. Okay, but what's really cool is how this whole idea works even for the simplest possible problem. So let's zoom way in. Forget the self-driving car. Let's think about a little robot vacuum in a world that only has two squares, A and B. And get this, the robot's entire brain is just this simple little table. That's it. It's just a couple of if-then rules. If its sensor says the square is dirty, it sucks. If the square is clean, it moves to the other one. That's the whole program. This, right here, is a rational agent in its purest, simplest form. Okay, but that's a two-square room. How in the world does an agent go from that to solving a genuinely complex, messy, real-world problem? Well, it does it by taking all that messiness and turning it into a formal puzzle it can actually solve. Let's use a classic AI example. Imagine you're in a city called Arad, in Romania, and you've got a flight to catch tomorrow in Bucharest. To you and me, that's a road trip. But to an AI, it's not about the views or the gas stations. It's a formal problem, something that can be broken down into pieces. To actually solve this, the AI needs a kind of recipe with 5 key ingredients. It needs to know, what's my starting point, my initial state? What moves can I make? The actions. What happens after I make a move? The transition model. How do I know when I'm done? The goal test. And finally, how do I measure how good a solution is? That's the path cost. So, Let's apply that recipe to our Romania trip. The initial state? Easy, we're in Arad. The actions? Drive to a city next door. The goal test? Simple question, am I in Bucharest yet? And the path costs we're trying to minimize? The total number of kilometers we drive. See? By framing it like this, it's not a road trip anymore. It's a math problem. It's a search. And once the problem is defined, just like that, the agent can finally start its search. And it's not just driving around hoping for the best. No, it's systematically exploring a map of all the possibilities. Now, here's a really important distinction. The AI isn't looking at a normal map, what we call a state space graph on the left. That just shows how cities are connected. Instead, it builds something called a search tree, like what you see on the right. And here's the absolute key. A search tree isn't a map of places, it's a map of paths. And this is the crucial difference. Let's look at the state space graph. A dot, a node, is just a city, Sibiu. But in the search tree, a node is the entire journey to get there, like the path Arad to Sibiu. This is what lets the AI keep track of every single possible route all at once. The actual search process, it's actually beautifully simple. The agent starts at the beginning. It keeps a to-do list of all the unexplored paths, which is called the frontier. Then it just repeats a simple loop. Grab a path from the list, see where it can go next, add those new longer paths back to the list, and it just does that over and over. Choose, expand, add, until pop, one of those paths hits the goal. And we can see that exact process right here. It starts at Arad. The first items on its to-do list, its frontier, are the neighboring cities. Let's say it picks the path to Sibiu to explore next, okay? Now, from Sibiu, it adds new paths to its list, including one to Fogaras. Next, it expands from Fogaras, and there it is. Bucharest is now on its list. Goal found. The solution is just the path it took to find it. Arad to Sibiu, to Fogaras, to Bucharest. Done. And this whole idea of defining a problem in a really strict way and then searching through this tree of choices, this isn't just a clever trick for road trips. This is one of the absolute fundamental building blocks of artificial intelligence. I mean, just think about it for a second. What is a game of chess? It's just a gigantic search tree, right? Where every node is a different arrangement of pieces on the board. What about planning a delivery route for a fleet of trucks? It's a search for the cheapest path. Even proving a math theorem can be thought of as searching for the right sequence of logical steps. It's the same powerful idea, just dressed up in different clothes. So you see, it all comes back to this one simple, really elegant idea of what it means to be rational. It's not about being human. It's definitely not about being conscious or having feelings. It's just about building a system that does the right thing, given what it knows and what it's trying to achieve. And that kind of leaves us with a final thought to chew on. If this pretty simple method, exploring a tree of choices to find the best way to a goal, is how an AI solves problems, what are the search trees that you navigate every single day?